Good morning, everyone. It is a great honor to address you at the Dr. APJ Abdul Kalam Endowment Lecture. The universe is vast yet connected by invisible forces. Today's event will bring together brilliant minds, bold ideas, and bright discussions. We are here today not just to celebrate knowledge, but to reflect on a profound question that has echoed through time. Why go to space? The answer lies in our drive to explore the unknown and our mission to better understand the universe and our place within it.
From the ancient astronomers who gazed at the stars to the modern day scientists who send missions beyond our solar system, every step into space takes humanity forward. Today, as we listen to luminaries and thinkers, let us remind ourselves that exploring space is not about leaving Earth. It's about securing a brighter, more informed future for our home planet.
I believe that prayer is our powerful contact with the greatest force in the universe. To begin this inspiring day, let us invoke divine blessings to guide our journey of learning and exploration. With this thought in mind, let us begin our day by invoking the divine with a prayer song followed by Tamil Thai Valthu. Kindly rise and join in this moment.
Lord, make us instruments of your peace. Where there is hatred, let your love increase. Lord, make us instruments of your peace. All the pride and prejudice shall cease. When we are your instruments of peace.
Where there is hatred, we will sow His love. Where there is injury, we will never judge. Where there is striving, we will speak His peace. To the people crying for release, we will be His instruments of peace.
When we are your instruments of peace. All the pride and prejudice shall cease. When we are your instruments of peace.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராரும் மதனமென திகழ்வரத கண்டமிதில் எக்கணமும் அதிசிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் வழங்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறமையான செயல் மறந்து வாழ்த்ததுமே வாழ்த்ததுமே வாழ்த்ததுமே.
We are reminded of the incredible diversity of the universe, from the majestic spiral galaxies to the tiny atoms that make up our bodies. The universe is full of wonder and awe. Every exploration begins with a warm welcome, a small step that leads to great discoveries. I now invite Professor Mary Diana, Assistant Professor, to extend a heartfelt welcome to one and all.
A very good morning to one and all gathered here. In the special occasion, it is my profound duty to extend a heartfelt welcome to Reverend Father K. Amal S.J., Secretary of St. Joseph's College, whose tireless efforts and visionary leadership have guided our institution to excellence. We are truly privileged to have you with us today. Welcome, Father. I extend a heartfelt welcome to Dr. Natchimuthuk Gopalaswamy, Astrophysicist, GSFC, NASA, Maryland, USA. Your expertise and achievements have significantly contributed to the field, inspiring generations. Welcome, sir. It's my distinct pleasure to extend a very special welcome to Dr. Sundar Raman, former scientist, Indian Institute of Astrophysics, Kodaikanal. We are deeply grateful for your presence, which honors our institution. Welcome, sir. It is my honor to welcome Dr. Akilan, Director, Anna Science Planetarium, Trichy. Welcome, sir. A warm welcome to Dr. I. Johnson, Head of the Department, who has been driving force behind this event. Your dedication to excellence and commitments to student success are truly commendable. Welcome, sir. Additionally, we are privileged to have Dr. S. Anvarasil, Association President, whose efforts in promoting scientific advancements and commitments are inspiring. Welcome, sir. A warm welcome to the faculty members and the students of Department of Physics. Welcome you all for this endowment lecture. Today's lecture is a testament to our institution's commitment to excellence in education and research. We gather here to explore new ideas and celebrate the pursuit of knowledge. Dear students, your participation plays a vital role in the success of this event. Let us seize this opportunity to learn, share, and grow together. Thank you.
I take great pleasure to request Reverend Father Secretary to honor our esteemed Chief Guest, Dr. Natchimuthuk Gopalaswamy, with a shawl.
I extend a warm welcome to Dr. I. Johnson, Head of the Department, to present a memento to our distinguished Chief Guest. I request Reverend Father Secretary to honor our guest, Dr. Sundar Raman, with the shawl.
I request Reverend Father Secretary to honor our guest, Dr. Akilan, with a shawl. I request Dr. I. Johnson, Head of the Department, to honor our Reverend Father Secretary with a shawl. Thank you all.
Just as the star shines brightly in the vast expanse of the universe, our Reverend Father K. Amal, the Secretary to a man of union, who unites all of us to work together for the greater purpose. Hence, I take great pleasure to lay a welcome mat to Reverend Father K. Amal to
the gathering.
சைடில் செவத்தோரம் கையில்
Good morning to everyone. I deem it a great privilege and honor to be in the midst of stalwart and versatile scientists in the form of Dr. Natchimuthuk Gopalaswamy and Dr. Raman. Our own alumnus is a great scientist. And the others on the days, as well as professors, my dear students, sitting in the aula. I feel very happy, jubilated, for the simple reason I have found after a long time that the contemporaries of my own time, and Dr. Raman has completed his studies in the year 77, and we belong to the same batch. I also completed 77 my undergraduation. On inquiry, I found out Dr. Natchimuthuk also was doing his studies, not here, but in Coimbatore, around the same time. You feel very happy, no? Because you become nostalgic about your own friends of yesteryears. And you feel proud of them, and you find them doing wonders, serving the nation, serving the student community and professors, empowering them with the new knowledge. University or college, for that matter, is invited. By definition, university means to discover new knowledge in order to address the new issues and problems, the new challenges we face today. From that perspective, when I look at Dr. Natchimuthuk Gopalaswamy, he is the right person to be here to speak on why go to space. Our forefathers, hundreds of years, thousands of years back, they've done two important things when they lived here, and they have passed on the knowledge, and they transferred the knowledge to us, and we enjoy even today. One thing is to traveling towards the vertical line upward. The other travel is traveling from within you, which is also a mind-boggling exercise. It's not an easy task to travel within yourself. It's almost challenging like traveling into the space. And our own forefathers have contributed their might, and they keep sharing through their written or in the form of stories, in the form of episodes, and you come across very many things. And we have the right person today. I really appreciate and honor and commend the Department of Physics, particularly our HOD, Dr. Johnson, in the company of others, who have organized this program. Young people, you travel, you go faster, you are on a fast track, you are on an expressway, we are all a little slow, and you can travel into the space because there are hundreds and thousands of solar system in the universe. Probably wherever you travel, wherever you go, you can find out 100 million space. Which space you are going to land, I do not know. You'll have to close your eyes and travel. You can dream, as Dr. Abdul Kalam invited us, dream big. And today is a day that you can dream big in order to reach the space, outside space. I'm happy to felicitate, offer my felicitation and appreciate and place on record my own gratitude on behalf of the Jesuit management to the Department of Physics. And I'm sure you, the company of all the professors and the scientists sitting here, you will have a wonderful travel today. All through the day, travel, take a big journey, take a leap in your life, and God bless all your efforts. Thank you and God bless us.
Let us offer solemn thanks to Father K. Amal for the memorable and passionate address.
Every star in the sky has a story to tell, and every scientist has a mission to inspire. To introduce our distinguished chief guest, Dr. Natchimuthuk Gopalaswamy, I now invite Dr. I. Johnson, Head and Associate Professor of Physics. Dr. Johnson will highlight the remarkable achievements and contribution of our chief guest, a leader who has expanded humanity's understanding of the universe.
A very good morning to all. It gives a great pleasure for me to welcome not only Dr. Natchimuthuk Gopalaswamy, but along with the other two eminent star wars in space research. So the Department of Physics is used to have a long term of collaboration with the Indian Institute of Astrophysics in many ways. So when I took charge as head of the department, the first talk has been given to the department was from the director of Indian Institute of Astrophysics in Bangalore. So our alumni are also working at present also in Bangalore at Indian Institute of Astrophysics, Solar Observatory, Rajasthan, and so on. So the contribution of the physics department is not least one, but it's a maximum one. It has had many scientists, including His Excellency Dr. APJ Abdul Kalam for his space research. So in this aspect, we are having an eminent scientist, international figure in the field of space research, who is the right person for this Dr. APJ Abdul Kalam, who is not only a space man but also a missile man. So the Dr. APJ Abdul Kalam spent his entire life not only for India but also for the international arena in terms of bringing space research to the common people usage. We always used to say, think globally and act globally. So that was his proverb. So he used to try to connect the space with the land, not just in simple terms, but also in the complicated ways to help the complicated problems, to solve the complicated problems of the common people, especially weather forecasting, disaster management, and so on. So weather forecasting and disaster management and together with the climate change are the hottest areas nowadays in which the mankind needs a lot of help from scientists and especially space scientists. One time one astronomist, when I met him in Colombo, he told me the problems in the earth are not purely due to earth, partly due to astronomical nature. So this shows how we can focus on space and astronomy or astrophysics so that we can solve the problems of a common man. So this is an important aspect in which we are having eminent three-star walls starting from Dr. N. Gopalaswamy, Dr. Sundar Raman, an illustrious alumnus of our institution, and Dr. Agilan, the director of the Anna Planetarium Science Center, Trichy, who was a well-wisher for our department and the college. I welcome all of them on behalf of the management. Welcome, sir. Dr. Gopalaswamy is a staff scientist at the Heliophysics Division of NASA's Goddard Space Flight Center, Greenbelt, Maryland. He has done wonderful work in astrophysics in many aspects, which will be highlighted by Dr. Sundar Raman. He published nearly 400 research papers in high impact factor journals. He held various prestigious positions in USA. He is an astrophysics at NASA Goddard Space Flight Center, Maryland, till now. And he was a senior research associate, National Research Council, National Academy of Sciences, USA. He worked on the relation between coronal mass ejections and solar radio bursts. He was the research professor at the Catholic University of America in collaboration with the NASA Goddard Space Flight Center. He was an associate research scientist at the University of Maryland, College Park, USA. He was the assistant research scientist at the University of Maryland, College Park, and worked on radio bursts and coronal mass ejections. He was the research associate at the University of Maryland. He was the resident scientist at the Indian Institute of Astrophysics, Kodaikanal Solar Observatory for quite some time. And he analyzed the various operations of the Kodaikanal Solar Observatory. He was a visiting scientist at the Indian Institute of Astrophysics, Bangalore. He was a scientist who was sort of space research in all over the world by many eminent people in this field. He was a member of various international scientific bodies. And he held many prestigious positions in various universities as visiting scientist and visiting professor. So the list goes endless. So I want to put a full stop so that my follower, Dr. Sundar Raman, will highlight the more, can give more introductory remarks about our prestigious scientist, Dr. N. Gopalaswamy. Thank you, one and all. Welcome, sir. It's my wholehearted wishes to felicitate, welcome our beloved Reverend Father, Secretary Dr. Amal, SJ. So Father was so kind enough always to move towards the physics department students. So whenever he comes to the physics department, he used to say, I feel young because I am seeing so many young faces, enthusiastic faces. I welcome you, Father, on behalf of the physics department. So in absence, I thank Reverend Father Rector and Reverend Father Principal who were eager to come, but due to some other preoccupied arrangements, they couldn't come in the last minute. I welcome them also. I thank one and all for this wonderful gathering. I hope that this session will be a very fruitful and useful for the student community by and large.
The universe is governed by law of physics. The stars and galaxies are connected by an invisible web of gravity and light. We are connected by our shared passion for knowledge and discovery. Let us put our hands together to welcome Dr. Sundar Raman, retired scientist, to address the gathering.
Namaste to all of you. It's indeed a great pleasure for me to be here in this on this occasion, as I feel personally that it is extremely difficult to bring a person of stature of Professor Gopalaswamy to our college, and it's mainly because of the tireless effort of Professor Johnson, and then the coordination with Dr. Akilan. And so all the three of Dr. Akilan, Professor Gopalaswamy and Professor Johnson, we have been associated for more than 40 years, so to say, for that matter. and it's a pretty long time actually. And it's heartening to note that Dr. Ramal also, Reverend Father Ramal also belonged to he's also our contemporarian. And I would like to mention that, of course, the list of whatever positions that has been held by Professor Gopalaswamy has been mentioned by Professor Johnson. But in addition to that, what I would like to mention that, we both worked together also. We studied in the same batch. Of course, I was here and then he was at Coimbatore and he was a gold medalist. So he not only had an illustrious academic career, but also he has student career, but also right up till now, he has an illustrious academic career in NASA. And he was the resident scientist and I was his successor. And so I retired as a professor in astrophysics and 10 years back. And we have been associated for more than 40 years in this particular aspect of field. And more so ever, we worked together in the same field of space weather sun earth relations. How the solar radiations, they affect our atmosphere and how in the process, it is going to be the dark side of the sun, we studied actually together. Of course, I am in the optical and he was in the radio, and then not only that, after going there to NASA, he studied in almost in all multi-wavelength observations. And so I am really grateful to the management of St. Joseph's College and making Professor Johnson to invite Professor Gopalaswamy. He has a very tight schedule, and despite that, he was ready to come here, and mainly because of that, we have invited him. And we always admire, that what I can say, sports person. Yesterday we have been, praising about Guhesh, who made the chess champion. And of course, we know pretty well about Sundar Pichai. But hardly we know about our brilliant scientists who are working in the field of science all through the globe. He is one among such person. And I am very happy to mention that mainly because we both worked in the same field, particular field. So, and he has got enormous students all through the globe, and also he has been in the board of studies of many of the universities in the global level. So let me take the pleasure of welcoming Professor Gopalaswamy on my request and on Professor Johnson's request to visit our institution. And so let me talk more time, mainly because I thought that Professor Gopalaswamy will be able to address the students for at least 45 minutes. And with that, I conclude that. And it's an opportunity for all of us to be here with you people to share and to hear the science behind what Gopalaswamy is going to talk. Thank you very much.
Thank you, sir. Now we have reached the core of today's event. Let us put our hands together to welcome our guest, Dr. Natchimuthuk Gopalaswamy, to address the gathering on the theme, Why Go to Space?
Okay. All right. Vanakkam, good morning. என்னுடன் மேடையில் அமர்ந்திருந்த அறிவுசால் பெருமக்களே, பேராசிரியர் பெருமக்களே, மாணவ செல்வங்களே, பிற விருந்தினர்களே, உங்கள் அனைவருக்கும் எனது நன்றி. ஏனென்றால் உங்களை போன்ற இளைஞர்கள் எதிர்காலத்தை நிர்ணயிக்கப் போகின்றீர்கள். உங்களுடைய பங்களிப்பு இந்த உலகத்துக்கு மிகவும் தேவையானது. நாம் முன்பு கேள்விப்பட்டது போல நமது முன்னோர்கள் நிறைய சொத்துக்களை நமக்கு சேர்த்து வைத்து போயிருக்கிறார்கள். குறிப்பாக இயற்பியல் மாணவர்களுக்காக ஒரு அருமையான திருக்குறளை எழுதி விட்டு போயிருக்கிறார் திருவள்ளுவர். அது என்னவென்று உங்களுக்கு தெரியும், ஏனென்றால் நீங்கள் இயற்பியல் மாணவர்கள். தெரியாது என்றால் சொல்லிவிடுகிறேன். எப்பொருள் யார் யார் வாய் கேட்பினும் அப்பொருள் மெய்ப்பொருள் காண்பதறிவு. அதுதான் பேசிஸ் ஆஃப் அனாலிசிஸ். இன்னைக்கெல்லாம் நிறைய சோஷியல் மீடியா ஊடகங்கள் நிறைய இருக்குது. என்னென்னமோ செய்திகள் வருது. சிலது நல்லது இருக்கும், சிலது கெட்டது இருக்கும். ஆனால் அதில் சரியானது எது அப்படின்னு சொல்லிட்டு உண்மை தெரிஞ்சுக்கக்கூடிய முயற்சி உங்களுக்கு ட்ரைனிங் ஏற்கனவே கொடுத்துருக்குறாங்க. இனிமேல் அந்த ட்ரைனிங் நீங்கள் வளர்த்து எடுத்துகிட்டு போக போகிறீங்க. அதனால் இந்த கூட்டத்தில் எனக்கு பேசுகிறது ரொம்ப பெரிய மகிழ்ச்சி. எனக்கு கொடுக்கப்பட்ட தலைப்பு, எதுக்காக விண்வெளிக்கு செல்கிறோம். இது உங்களுக்கு ஏற்கனவே நிறைய தெரிஞ்சிருக்கும். இப்பெல்லாம் செய்திகளும் அறிவு சில்லுகளும் அடிக்கடி உங்களுக்கு ஊடகங்கள் மூலமாக கிடைக்கின்றன. அதனால் உங்களுக்கு தெரிந்திருக்கும். இருந்தாலும் அதை ஒரு வகைப்படுத்தி உங்களுக்கு சொல்ல வேண்டும் என்று இங்கு நிற்கிறேன். அடுத்ததாக, என்னுடைய ஆராய்ச்சி பெரும்பாலும் ஆங்கிலத்தில் நடைபெறுகின்ற காரணத்தினாலே என்னுடைய இந்த உரையை ஆங்கிலத்தில் செலுத்த விருப்பப்படுகிறேன். So why do you want to go to space? Space is nothing but it starts from ground up. The whole Earth is located in space, but we specifically refer to the layer outside of our atmosphere, where the influence of Earth is very small, where the matter that we are going to see in space is different from the matter we are living in. So we are living in the neutral atmosphere, where we have air that we use for our breathing, and then we live the atmosphere. Beyond the atmosphere we have what is known as ionosphere, and then we have Earth's magnetic field is protecting us from outside radiation that is called the magnetosphere. And if you go beyond the magnetosphere, then you have the interplanetary space, then the interstellar space, then the intergalactic space, and the universe. So the universe is basically nothing but contains galaxies, and the galaxies contain stars. Stars have planets, and then in addition to planets, you have smaller planets like comets, asteroids, and we also have all those things. So the basic curiosity, of course, people had always to understand the existence of all these objects in space. So I can list a few things. This is not an exhaustive list, that why we go to space. And then I will elaborate on each one of those a little bit. So first is curiosity. Of course, we always want to know something. Even if you can recall, you have done some good things or stupid things, but out of curiosity, you wanted to know something about certain things, right? It could be any incident. You can go back up to your 4 or 5 years old. You can think about things, and we are always curious. All humans are curious. And one particular curiosity is very important, because we all want to know, all the humans living in this planet of 6,000 kilometer radius, spread all around, are we alone? Are there other planets or other galaxies? Maybe in other galaxy you have a planet like Earth, and there may be people, there may be life forms available there. So we always have this curiosity. Then, of course, one important thing is utility. how can we make use of space for our own betterment? Okay, so for example, we are frequently going to the moon, and moon was formed around the same time as Earth was formed. So it can have all the minerals that we have on Earth, and the moon also, on other planets, that is rocky planets in the solar system. Then space provides a lot of service. You know, everybody having a smartphone, you will know GPS. This is a GPS receiver, right? So we can get information about places. You can have the map. You just somebody asks you to go to dinner to this restaurant. You can put the coordinates and you can walk there or drive there. So there is a lot of services. And similarly, you can think about even farmers doing tilling using tractors. They have a GPS attached to it, and they can do precise agriculture. Then you have new platforms for observing the universe, right? So from ground, we cannot observe at all wavelengths, as you know, because the atmosphere absorbs certain wavelengths. We only have a very small window that is open to us, namely the visible light. For example, if you want to observe X-rays from our sun or another galaxy, you cannot, because the atmosphere absorbs all the X-rays. Then finally, if you want to see what is the material up there, we can directly probe it. It is called in situ observations. You might have heard from doctors doing in situ treatment. Basically, that means you're directly going to the place which you want to observe. So there are two ways. So you can, for example, observe the temperature outside. You use your phone and find out what the phone is telling you about, okay? Or you can open the window and stick your thumb outside, and that is in situ observation. So you're using the thumb as a sensor, and you see it is hot or cold. Of course, the accuracy is not very high, like a thermometer, but you can say whether it's cold or hot. Or you can take water. குளிக்கிறதுக்கு முன்னாடி கை தொட்டு பார்க்குறோம் இல்லையா, சூடாக இருக்குதா, சரியாக இருக்குதா, ஹாட்டாக இருக்குதா அப்படின்னு சொல்லி நம்ம தெரிஞ்சுக்கிறோம். That is in situ observations. So to observe the space, what kind of magnetic field, what kind of particles they have, you have to go up there and stick out a probe to measure those things. So I would basically elaborate on this in the next about half an hour or so. So the first thing is the curiosity aspect. What you see is a picture taken by the James Webb Space Telescope. And you see some things here. The so the one with where you see this kind of streaks, these are stars in our galaxy. So you will see a few of them, but everything else actually is a galaxy. It is not a star. All the fuzzy things are galaxies. That means there are so many billions and billions of galaxies. People have estimated something like 200 billion to 1 trillion galaxies in the universe, in the known universe. So whichever directions you see, you have galaxies. And each galaxy has 100 billion stars. And each of those stars can have planets. Okay? So the James Webb Telescope is one of the important platforms that is available to us to see the oldest things in the universe, the faintest thing in the universe, and the farthest things in the universe. And this is possible because we are able to go to space and observe from there. Okay. So the curiosity aspect, you probably should know about this person. So this famous wise man from Italy who lived in 1548 to 1600, Giordano Bruno, he had this excellent argument that innumerable celestial bodies, stars, globes, suns and earths may be sensibly perceived therein by us, and an infinite number of them may be inferred by our own reason. So he definitely thought, for example, he didn't say the sun, he said suns. That means he already understood all the other stars are suns. So sun is a star. And interestingly, only after 400 years, just little more than 400 years, we had this Kepler mission. The Kepler mission already identified more than 2,600 exoplanets, planets going around other stars. So that's why you should have dream big. You should be able to achieve things, even if you have a faintest idea, pursue it. And it is possible for the humanity to pursue it and prove that he was right. So the James Webb Telescope is located in this place called L2, this position. So there are many key important points in the Sun-Earth system where the balance between the pull of the Sun and pull of Earth balances out. So if you put something there, it remains stable. These are called Lagrange points. And James Webb Telescope is located at L2. So it can look away from Earth and avoid all the Earth's lights and pollution, light pollution. But if you want to study Sun, of course you have to look at the Sun like this. And we have many missions located around L1. That is the point between the Sun and Earth. You can look at the Sun. And in fact, the recent Indian mission launched last year, Aditya L1, is located here, along with a bunch of spacecraft sent by ESA and NASA. And then, of course, if you want to observe Earth, we have to look towards Earth. We go to space and look down. And for astrophysics and solar physics, we go to space and look away from Earth. Okay? So, for example, the remote sensing satellites are located around the Earth and they look towards the Earth. So the immediate utility for us is weather prediction, right? So weather prediction requires measuring atmospheric temperature, precipitation, wind, snow and ice cover, large-scale fires, volcanic eruptions, seasonal weather patterns. You need to measure all these things to understand and predict what the weather is. You simply look at your cell phone and you can find the weather. That is, there's a lot of work goes behind it. And we have to produce a lot of sensors like infrared sensors, Doppler radar, temperature and humidity sensors, cameras are in different wavelengths, and also sensors for wind speed and precipitation. Currently there are 322 meteorological satellites working and gathering this information. And also we have about 1,200 ground stations in India to make some of these measurements and to combine with the space observations. Finally, some of you are interested in studying further modeling and stuff like that. So all this data are collected and put into computer models so you can predict what the weather is going to be in Trichy, what's going to be in Alanganallur or whatever place you want to know. But of course you cannot measure in every single centimeter in these places, so you have to have model, so you extrapolate between observations. So this is this morning I just took a screenshot of my cell phone, and it gives me the weather in Trichy, 75 degrees at that time. That's in Fahrenheit. Okay, you know how the formula is. C over 100 equals 180 by C F over 180, F minus 32 over 180. You know the formula, right, how to convert, right? So it gives a lot of information, and this information is produced by people combining space and ground-based data. And then they also produce daily reports like this. You can go online and then read these things. So this is the weather within our atmosphere. And we know how to manage the weather. If it's a big weather, lot of rain outside, you stay inside, right? But you have to go somewhere. What will you do? You take an umbrella. So the umbrella is a mitigating factor. So you know how to manage the weather. But in space, first of all, the gas is extremely thin, but it is not neutral. All the material is ionized in the form of plasma. You know plasma, you are physics students, right? You take water, heat it, it becomes vapor. You heat the vapor, then hydrogen and oxygen separate. You further heat, then get ionized. So the ionized state is called plasma, and the space is plasma. And there is magnetic field from the sun penetrating this plasma, and magnetic field from the earth also spreading into space. So it is completely different environment than what we are living in the atmosphere, which is a very comfortable, cozy place. But space is not so. That's why astronauts have to have all these gadgets and garments before they can venture out. So we have large number of spacecraft all around the Earth. So here is your Earth, and this is the magnetic field of Earth, and this area is called the magnetosphere. Once you leave the magnetosphere, then you are in the interplanetary space. There, everything is completely different. So we are talking about space is this one, which is called near Earth space or inner heliosphere. But outer space and even far away, you can extend beyond the solar system and so on. But we know the sun as a fantastic object because we get all our food and fuel from the sun. Can you think of any food item that cannot be linked to the sun? Think about anything. Can anybody think about a food that is not related to the sun? Because all food is produced by photosynthesis. And the photosynthesis, the photo comes from the sun. For those people who are not vegetarians, you have meat. And that meat also comes because cows and goats, they eat grass, and grass grows out of photosynthesis. So even cows and goats, they're also from the sun. And in next month, we are going to have pongal. The rice comes from that. And some of you might know what this is. This is called tambu. Right? You put animals together and then ask them to be a machine to extract the seeds or milk from the stock. So it's energy. That energy also ultimately related to the sun. Right? So milk, another product, oil for cooking, all these things are due to photosynthesis that you all know, right? And then from this additional processes to produce protein and fat. So for us to live, we need fat, protein, carbohydrate, and all the minerals. Now the minerals are not from the sun, right? all the heavy elements, they're not from the sun. I'll come to that. Then finally, oil that we use for our cars and automobiles, or the coal we use to produce our energy, that's also from the sun. Is there any connection? Because coal is nothing but trees which lived millions of years ago and got buried underground. And similarly, other living things like planktons got buried underground and they became oil. So they are also from the sun because those trees, they grew out of photosynthesis. So sun is an important object for us, that's why. And this is the bright side of the sun. Everything, all the energy that comes from the sun except nuclear energy, the nuclear energy comes from heavier elements like uranium, and they are not made in the sun. They are made in the insides of very massive stars that lived long ago. And then they explode and spread their material into space, and the material collapses and you form stars like the sun and planets, and we are able to get those from those older stars. So all those people wearing gold, think about it. Your gold is, you're directly related to another big star. It's not to the sun. You got your gold from other stars, in the interior of other stars. But then sun has a dark side. Outside when you go through a telescope, you look, it looks nice, except for few sunspots today. Your friends were showing me the telescope. They have several sunspots on the sun because right now sun is very active. We are in the solar maximum. And a situation basically like this. Then the sun erupts and produces a lot of mass. And these are called coronal mass ejections because they come from the solar corona. And they have mass ranging from, 10 to the 5, 10 to the 12 to 10 to the 17 grams. It's like billions and billions of tons of material is ejected very fast with speeds up to 3,000 kilometers per second. In 1 second, they can travel 3,000 kilometers. And they can come and hit Earth and disturb our magnetosphere and produce currents in the magnetosphere that can damage our electrical power grids, they can damage power lines, and so on. So this is the dark side of the sun. For example, this big explosion that took place in 2003, and you see all those sandstorm-like things, they are energetic particles accelerated by the coronal mass ejections. They come and hit the detector, which is imaging these mass ejections, and produce this noise. And what you see is a measurement from a ghost satellite from space, the energetic protons produced by these kind of explosions. What you see here is the background level is about 10 to the minus 1 units. When you have an eruption taking place, the intensity goes up by several orders of magnitude, 10,000 times, 100,000 times more. Okay? So these are energetic particles. It's almost like you're sitting near a exploded nuclear reactor. All the radiation you have to absorb. So we have to protect ourselves and our satellites from these kind of events. The same two events, when they hit the Earth, they produce geomagnetic storms. That is, they shook the Earth's magnetic field, and the Earth's field feels as if it has no magnetic field for a couple of days. Okay? So there are a lot of consequences for this kind of geomagnetic storms. They can heat the atmosphere to such an extent that satellites can be destroyed. In 2022, you might have heard about Starlink satellites. There are 38 of them. They dropped into the atmosphere and burnt because of a small geomagnetic storm like the one I showed. This is a burnt up transformer in 2003 because of this big geomagnetic storm. So imagine whenever you have a change in magnetic field, you produce current, right? dB/dt. Remember your equations. And then we know that sun directly affects Earth because we are looking at this at Earth from a different view. So here's the sun, here is Earth, and you see the disturbances coming from the sun, they go directly hit Earth. And that's what causes the geomagnetic storms. And the origin of space weather is because of the sunspot regions on the sun, which are regions of very high magnetic field. And because of the gas motions on the surface of the sun, the magnetic fields are twisted and turned, and they store energy, and then suddenly they release the energy in the form of solar flares and coronal mass ejections. So you can imagine you take a rubber band, you keep twisting it, and you can convert that into a frog, it will just leap. If you release it, it will leap. So where did the rubber band get the energy from? From you, because you are twisting it. You are spending energy, that energy is stored in the rubber band, and the rubber band jumps. Same way, because of the photospheric motion, because the sun is not very nice as we see outside, it's a gas, there is always convection going on the surface, and the magnetic field lines suspended in those gases, they keep moving around and get twisted and store magnetic energy, which is released in the form of coronal mass ejections and flares. The typical energy in a solar flare is 10 to the power of 32 ergs. You convert it into joules. And in the mass ejections is 10 times more. It's like 10 to the power of 33 ergs. So all these observations are made from space. The space weather can cause enormous amount of loss, damage, because satellites can be lost, transformers can be burnt, pipelines can be broken. And then if electricity is broken, there are a lot of secondary effects. If there is no electricity and you need money, you want to go to the ATM, will it work? It won't work. So you cannot get money. You want to use your Google Pay or Apple Pay. If you cannot charge your phone, you cannot use them. So we are actually dependent a lot on space. There is no GPS work, so you cannot get to a place if you are always used to GPS maps. Then you have to go back to your old system, and you may not have a map stored in your house. Now, I mentioned in the beginning a window, atmospheric window. The only visible light is very short wavelength, frequency range 10 hertz, 100 hertz, some in this range. Okay, visible light. And we call this optical spectrum because our optical window is only this much. But the electromagnetic spectrum is very vast. We also have a small window called radio window here. And we can receive radio waves from our galaxies, from the sun, if you have a radio telescope working in some frequency range. Maybe in this anywhere from 10 megahertz to about 100 gigahertz. Beyond that, we cannot observe radio waves. But we know all these objects, they emit entire electromagnetic spectrum. So if you want to observe gamma rays, what do you have to do? You have to go outside the atmosphere, because the atmosphere is the one which is blocking it. So for example, this graph shows a gamma ray burst from the sun. Okay, it goes up and comes down, and it is observed by a satellite called Fermi satellite. It observes gamma rays, and you can make the connection between these are radio waves in the 10 megahertz range and the gamma rays in zeta hertz range, very high frequency, but they are closely related, and these are optical observations from space. By combining all these things, we can learn a lot about the sun and what kind of eruptions it produces, what kind of flares, what kind of CMEs, and so on. As I mentioned, the mass is very high, very enormous amount of matter is ejected. And here is a mass ejection from the sun. This is the sun, and this is an artificial ecliptic disk that we produce to observe the sun all the time. Because in the past we observed this corona only during eclipse, and eclipse comes once in 2 years or so. So you cannot wait the day-to-day things happening on the sun. So you have to go to space, and then you can observe the sun with the coronagraph all the time. And the mass is, it's equivalent to about, each mass ejection like this is like 10 to the power of 9 elephants. That's the amount of mass. Of course, this is not a solid like a elephant, but it's only a gas, a charged gas, plasma. And the plasma contains magnetic field. And when an eruption takes place, it takes the magnetic field and plasma together, and occasionally it can hit Earth and combine with Earth's plasma and magnetic field and produce these geomagnetic storms, Kandapuya. And these coronal mass ejections energize particles to very high energies, and these particles stream towards Earth, and then they get trapped around Earth radiation belt. So this is Earth, and you have these radiation belts, the inner belt, outer belt. And whenever you have to launch a spacecraft, they have to go through this, where you have mega electron volt protons and electrons exist, and they can easily damage satellites. So we have to understand this. And all these streaks that you see here, these vertical streaks, each one of them is a big coronal mass ejection that accelerates particles to very high energies. Now, the energy of the particle is important, and it affects our atmosphere. You might have heard about ozone depletion, right? Ozone layer in our atmosphere. So, when you have low energy particles, they can penetrate only up to here, about something above the mesosphere of Earth. But when you have higher energy, they can go deeper and deeper, and some of them come all the way to the ground. And especially the 100 mega electron volt protons, they come to the stratosphere where you have ozone. So these particles, when they collide with the existing air molecules, they produce radicals. Radicals, they are charged molecules. And these molecules combine with ozone, and then when ozone is combined with these molecules, then it becomes something else. It's not going to be ozone anymore, and therefore the ozone density decreases. So to observe these particles, we have to go to space, because we're all generally stopped in the atmosphere. There are, of course, if you go into space, these energetic particles propagate into entire solar system. Okay? In 2003, when we had these big storms I showed in the beginning, the two explosions together which produced particle events and two geomagnetic storms, one of them actually destroyed an instrument on Mars, a Mars Odyssey mission. The purpose of that instrument, MARIE, was to survey the radiation environment of Mars, so in the future when humans go there, they know how to protect themselves. Unfortunately, the same radiation destroyed that experiment. But this is called space weather. Okay, you can have a house blown off by an hurricane, something like that. Now, space weather is not particularly affecting US. Of course, US was sending that to spacecraft, but it can affect anybody who is interested in sending a spacecraft to Mars. They have to worry about it. In fact, the Japanese sent another mission called Nozomi to Mars, and in 2022 there was another big mass ejection, which is shown here, this mass ejection produced a lot of energetic particles, and that destroyed the Japanese mission. So the energetic particle events don't care about whether it's Americans or Japanese or Indians or all, it affects all humans. So we call space weather is global. To understand these things, of course, we have to go to space to observe these particles. By the way, you might have heard about Nozomi, also is the name of the bullet train in Japan. Okay, there are a lot of bullet trains which travel very, very fast. And the meaning of, anybody knows Japanese here? Nobody studies Japanese? Okay, so Nozomi means hope. That's the Japanese word for hope. And these energetic particle events made it hopeless. Okay, so that's the situation. On Mars, you might have heard about the Curiosity rover here, and they have a particle detector. This particle detector senses these particles from the sun. You can see these big spikes. They're sudden enhancement in particles, and if you have an astronaut on the Mars, these things give a lot of radiation dosage. So they have to worry about these particle events on the Mars. Then, of course, as you know, when you go to space, you cannot take your spacecraft and plug it to the wall. There's no wall in space. So you need to have energy derived from the solar energy. So you have solar panels. Okay. The solar panels can also be affected by these particles. Here is a normal lifetime of a solar panel. Here is a big particle event, and here's another big particle event. And it reduced the lifetime of the solar panel significantly. So your solar panel can be affected. So the bottom line is, you have space is completely different environment. To observe it, to explore it, you have to go to space. And you have to protect yourself from these kind of hazards. So NASA has a separate division to take care of the space weather. All right, now let me go into some of the other aspects that I talked about. Right now I just talked about mainly sun, because sun is our star. It gives us life, and also it gives us hazards, so we have to live with this star. And NASA has a program called Living with a Star. You can Google and read about it. Living with a Star is a program which deals with all these aspects of the sun. Okay. Now, we can also use, of course, sun provides enormous amount of energy that we can tap into. And I think now we have solar panels coming up on the ground to tap that energy. Just to say that you have a lot of resources available for us. Then space is also big. You have a lot of objects in the space. You have comets, you have asteroids, you have moons, you have planets. As I said, they were also formed at the time of our Earth, and they possess similar material. And we can send a rocket there, can people there to dig out minerals and bring it here. It's possible. And space is freedom. This is an important slide. People have sought new lands to escape war, to escape tyranny and oppression throughout history. If you really ask your parents or grandparents and great-grandparents, they came from somewhere. They are not originally from Trichy. They came from somewhere else. So people have kept on migrating. In fact, my family moved from near here, near Karur, a place called Tennilai, moved to Coimbatore in 1700s. I call myself a Coimbaturian, but everybody can trace their origins to some other place. There is always migration for various reasons. So all humans have the inalienable rights of life, liberty, and pursuit of happiness. It becomes more and more difficult to uphold these rights on earth as societies scramble and compete for dwindling resources. When the population increases, we have to divide the resources and we get fight because of that. Space, with its vastness and vast resources, offers a lasting chance to secure these inalienable rights for future generations. Think about your 10th grandchild, great-grandchild. They may be facing a very different situation than today. In 500 years from now, think about it. Okay? So you have 20 generations later, you can think you still have your offsprings there, and their life may be a lot more miserable than what we have right now. Because we have more population, we have to divide the resources. So space offers an opportunity. For example, if you can migrate to Mars, we improve our technology and we are able to go and set up colonies there, we can spread out into space. We can have natural disasters. 60 million years ago, dinosaurs lived on Earth. And you have bones, you can go see in Washington, in Smithsonian, we have huge dinosaur skeletons hanging in, and they show to kids. Now, these dinosaurs were completely gone because of a meteor that hit a place in Mexico. So this is the Yucatan Peninsula in Mexico. It happened right here, and people have identified the crater now. It happened about 66 million years ago, and it's completely covered the atmosphere with so much dust, and they didn't have food, and then all the dinosaurs died. So we do have this finite danger to us. It can happen to us as well. And then we have, if there is a nuclear war, we never know, crazy people can always come to rule, right? And then they can wipe out the humanity because of all this. Then you can have global pandemics, and we recently faced one. How much disruption took place, you all remember, because of COVID, right? So, and then you have a lot of junk generated by the civilization. And that is the pollution, global warming, all these things are happening. And then we have an opportunity to get away from this in space. It may look very far-fetched, but it is doable. And about human migration. So, current modern anthropology, archaeology, and also genetics studies have shown that humans have migrated out of Africa and moved, traveled around. For example, in India, we had 4 waves of migration. 65,000 years ago, we had the original people called Vedite people. Then Elamite people from Iran came around 6,000 years ago. Then the so-called Aryans came about 3,500 years ago. Then we have Tibeto-Burman people moved into India. So we have a mixture of all these people inside India. And all these migrations happened because they wanted to have a better life somewhere, right? So we always move. And the only thing is this movement is all in 2D on the surface of Earth. But the migration I'm talking about is in 3D. We go vertically up. The only place humans live now is, where do humans live outside of Earth? Yes? Space station. International Space Station. It's only like 400 kilometers above. Okay? It's like going to Hyderabad from here. But in the vertical direction, which is difficult, and all the hazard I talked about. And then, of course, humans started exploring the space. Now we have more and more possibilities of astronaut going to moon again and to Mars. And of course, who knows, in the long run, when the technology is developed, they may go do interplanetary and interstellar travel. So I have another 10 minutes. I would like to give you some more idea about what is NASA doing. So you may be interested in this. So to give us a very simple way, what NASA goals is to expand human knowledge through new scientific discoveries. So we want to make discoveries, exploration and discovery. Extend human presence deeper into space and to moon for sustainable long-term exploration and utilization. Address national challenges and catalyze economic growth. Optimize capabilities and operations. This is basically what NASA does in various aspects. It could be exploration of planets, it could be exploration of the universe, it could be exploration of the sun, and then it could be remote sensing of Earth. All these are based on these few principles. We want to develop new knowledge for humans. So a space mission is not very mysterious. Okay? I talked about a lot of sensors, for example, to observe the Earth's atmosphere. So similarly, there are sensors to observe the universe, to observe the plasma in space, to observe planets, and so on. We have all these sensors. The sensors have to be spent into space. So we put all these instruments on a structure which we call spacecraft. And then we have mechanisms to move sensors to different places, to different orientations. Then we have antennas to send and receive radio waves. And then we need to have propulsion. Propulsion is the one which rocket takes you to space, and even after going there, you need to have small amount of gas which does the propulsion to change directions over there. The spacecraft can be rotated. For that you need fuel. Then you have all the remote sensing. You use something like your remote sensing car, you can operate your car like that, a very complex way of controlling all these instruments from ground. Then you have basically electric power is very much required. So we put all these things together, and each one of them you can expand into a group of engineers and scientists, and they all come together to form a space mission. So we need silicon and carbon for a lot of these sensors, and the silicon and carbon basically comes from the universe, as I said, because they are not produced in the Big Bang, they are not produced in the sun, it is produced by big stars. For example, this is a dust in a galaxy. So the black portion is basically dust, and that dust contains basically silicon and carbon. This month is very important. Okay? This month is important because the man-made object called Parker Solar Probe is going to touch the sun. It's going to closest to the sun that any man-made object has gone so far. So the distance is 9 solar radii. One solar radius is 700,000 kilometers. So it is going to be as close as 9 solar radius. And the temperature there is like a 500 suns. Outside your hot sun, you increase you make 500 suns in the sky, what will happen? That much heat it is producing, but man has made materials to withstand that heat and make observations, and it's still working, and this month it's going to do the final closest approach to the sun. And if you look at the material made of that made the spacecraft, it has got the big heat shield, which is basically carbon based and ceramic based. And you know ceramics is silicon based. So silicon and carbon, that is from the universe, is now we are making use of it to produce this kind of instrument that can go very close to the sun. So we are capable of doing this to any extent. You just imagine that you can go to another star and get a planet from there, and you can go there. There is also a practical reason. You know, sun, people say, is 4.5 billion years old, right? And it can live for another 4.5 billion years. We don't have to worry about it. But what happens after 4.5 billion years? Suppose humans survive here with all the possibilities of extinction, we are still survive. Then what happens? What happens is the sun expands. And towards the end of its life, it expands and attains a phase known as red giant. In the red giant phase, the sun is so big that it expands up to Earth's orbit and beyond a little bit. So that means the entire Earth is going to go into the sun. And then it explodes and becomes a white dwarf. So there is a real possibility that we have to develop our technology to migrate from the sun, or maybe temporarily move to outer planets, and then we have to survive. Then, in the interest of time, I'll skip some of those slides. I just wanted to mention that there is a nuclear power that many spacecraft use, and that is from plutonium. And I just to give some of these slides for materials, so if some of you are studying material science, I wanted to show that these materials are very, very useful. Silicon carbide is another important alloy we can use. It operates at very high temperatures, and the very lot of uses. For example, you can land on Venus where the temperature is 460 degrees Celsius, and we can make sensors out of the silicon carbide. They will not be affected by this temperature. Of course, I already mentioned about gold. And then this slide is important because this tells you how you get various elements formed inside massive stars. So for example, in the core, you have iron, and all the other elements are in various layers. When a star like this explodes, you get all this material thrown into space, and then over millions of years, these become clouds, and these clouds collapse to form a star, and then planets formed along with the star will have these elements, and that's how you got your gold that you're wearing on your ears and your neck. Okay? So this happens because a process known as fusion, thermonuclear fusion, and it happens inside our sun, and hydrogen is converted into helium, and 4 hydrogen atoms, if you measure 4 hydrogen atom and a helium atom, they will have different mass, and the missing mass becomes energy, mc square. You multiply that by c square, you get so much joules, and that is the energy we are getting from the sun. And this is an important contribution. By studying the sun, we are able to find a mechanism. Maybe in the future we'll have a fusion reactors on Earth. But only sun can do only a little, because it can only fuse hydrogen to helium, because it's a small star. The temperature inside is only about 15 million degrees. But massive stars have a lot more temperature in the middle, so they can fuse heavier and heavier elements. And you get all these materials, hydrogen, beyond helium, like carbon, neon, oxygen, and silicon. All these are produced in a very high temperature existing inside massive stars. And they typically have a mass something like 8 solar masses. So 8 suns put together will make a star, and those are the stars which make this kind of elements. So going to space, we can access this enormous resource available in other planets and moons and asteroids and comets. So with that, I come back to my last slide, which summarizes the stuff I talked about so far. So once again, I remind you that we want to go to space because of our curiosity. Not only because of curiosity, also it can be survival for various reasons. And space, we go to space for utility, because you can gain energy from there, you can gain minerals from there, okay? And then we go to space to provide services to humans for anywhere from GNSS. You know, GNSS means Global Navigation Satellite System, which India has, US has, Russia has, Japan has. And then we can do weather forecast, space weather forecast, as I talked about. We have new platforms to observing electromagnetic waves from the universe. And then finally, as I mentioned, we can directly probe the space by in situ observations. So I hope I gave you a glimpse of what is out there, and what you can do in the future to contribute. And with that, I thank you very much for listening. Questions? Questions, Kakra?
I am very much thankful to Professor Dr. Natchimuthuk Gopalaswamy for his wonderful brainstorming lecture. I hope that it is of great use for all the physics students, not only physics students, for all the science students especially. So now the session is open for discussion. So I restrict just 2 or 3 questions with because of lack of time. You can contact Dr. Gopalaswamy by email also for any other clarifications. Most welcome.
A very useful talk, sir. You really took us to the different parts of the universe through your interesting talk. Sir, any other further progress in the Big Bang theory or the formation of universe from NASA side, sir?
Speaker. Okay. So, of course, one of the most recent discovery is the gravitational waves, and now we have what is known as multi-messenger astronomy. So we use particles, you use electromagnetic waves and gravitational waves, and therefore we have new tools to understand the universe better, and the James Webb Telescope gives us the farthest galaxies, and you can estimate accurately the observable universe size.
Okay, in the very beginning, people say that Big Bang, massive object just burst something. Any idea on that particular massive object, the formation of that particular object or something, or it's just a force, it's a combination of forces?
I didn't get your...
The Big Bang theory, it needs some matter, right? So, any idea on that matter, sir?
So we can understand the complete structure of the universe today just based on the Big Bang theory.
Yes.
Where you have energy present in a very compact form and that expanded, and then you have all the elements formed, neutral material formed, radiation escaped from the material, and then with the inhomogeneity in the universe we have galaxies formed, and the galaxies have all the stars and planets and so on.
Yes, sir. Thank you so much.
Good afternoon, sir. Thank you for your mesmerizing lecture, sir. I have a doubt, sir. Usually, due to Doppler effect, if you are moving outward from the source will be, that sound will be decreases. Like that, when we are moving from inner part of the sun to outer part of the sun, it is reverse. In core, it is around 5800 Kelvin, but at that corona, we have million degrees Celsius. Why is it so happening in sun, sir?
Okay, so on the sun, the surface, yes, you are right, it's 5400 Kelvin, but in the corona, we have a million of degrees. So there is a few orders of magnitude increase in temperature. So, but the energy density, if you look at it, it's of course much denser on the sun. And the corona is made of not just plasma but also magnetic field. When you have a plasma with a magnetic field, you have a lot of different types of modes of waves. In the atmosphere, we have only one type of wave, which is sound. But in a plasma, you have many different modes of sound. One of them is we call MHD waves. So these waves propagate along magnetic field lines, and they, at some stage they cannot propagate further. So they deposit their energy in the corona, and that energy becomes heat. And the other things happen is a process known as magnetic reconnection.
Yes.
It happens between closed magnetic fields.
Yes.
When two closed magnetic fields of opposing direction come together, then they reconnect. And
Will it cancel each other, sir? If that in that active region, there will be connections between opposites, like magnetic knots like will be there. If it cancels, or only it will eject solar winds or mass ejections.
Right. So that is another mechanism. So these two mechanisms operate on the solar atmosphere, and that leads to the heating.
Sir, recently we had aurora at Ladakh, sir. Usually these auroras will happen in latitudes. Why it is happening in Ladakh nowadays?
So it depends upon the intensity of the event. If it is a very big event, so if you have a small, if I pour the water here, it will be just in this area. So if you pour a bucket, it will spread a lot more places. So it depends upon the energy of the event.
Thank you, sir.
Okay, I thank you the participants, because you can ask questions after some time also by email. You can contact our scientist directly. He will be happy to clarify your doubts, or he may be able to give more suggestions for your future career. I hope so. So thank one and all. So now we are living in an era of space shuttle. So from Trichy to US, maybe the flight time is 16 hours or 18 hours, 12 hours. But Elon Musk wants to reduce it half an hour or 1 hour. So that kind of speed with which the world is moving. Maybe within another 5 years it may come true. Perhaps we will be in a position to travel to US just within half an hour or 1 hour, like what we are traveling the town bus. So it will come true. The days are very speed, days of speed, days of fastness. So now I invited Dr. Agilan, the director, to say the concluding remarks.
அனைவருக்கும் மதிய வணக்கம். புனித வள்ளலார் கல்லூரியின் தாளாளர், முதல்வர், கல்லூரி ஆசிரியர்கள், அன்பு மாணவ செல்வங்கள் அனைவருக்கும் எங்களது அண்ணா அறிவியல் மையம் சார்பாக வணக்கத்தை தெரிவித்துக் கொள்கிறேன். இப்போ சார் பேசினது நம்ம கோபாலசுவாமி சார் பேசினது எப்படி இருந்தது? வெரி எக்ஸலண்ட். இது மாதிரி ஒரு ஸ்பீச் நீங்கள் லைஃப்பில் பார்க்குறது பெரிய அச்சீவ்மெண்ட்டு. அதனால் சாருக்கு எல்லோரும் சேர்ந்து கோரஸா தேங்க்யூ சொல்லணும். ஓகே, அது உங்களுக்கு புரிஞ்சுது புரியலைங்கிறது உங்களோட இண்டிவிஜுவல். நீங்கள் கவனித்து புரிஞ்சிருக்கலாம். நானும் பாதி கவனித்தேன், பாதி கவனிக்கலாம். ஆனால் அவருடைய ஸ்பீச் அந்த டாபிக் ஒய் கோ டு ஸ்பேஸுங்கிறதுல எதுக்கு நம்ம ஸ்பேஸுக்கு போகிறோம், அந்த ஸ்பேஸுக்கு போகிற நோக்கம் என்ன, டெக்னாலஜி நமக்கு வேணும், அதனால் உள்ள சைடு எஃபெக்டே சொல்கிறாரு. அதனால் இது ஒரு அற்புதமான ஸ்பீச்சு. இது மாதிரி ஒரு வாய்ப்பு கிடச்சி அந்த வாய்ப்பில் பேசின டாக்டர் என் கோபால்சாமி சார் அவர்களுக்கு எங்களது மையம் சார்பாக நன்றியை தெரிவிச்சுக்கிறேன். வெரி தேங்க்யூ, வெரி தேங்க்யூ சார். எங்களுக்கு இது மாதிரி ஒரு அடிக்கடி ஆப்பர்ச்சுனிட்டி கொடுங்க. எங்கள் ஸ்டூடெண்ட்ஸை நீங்கள் அட்வைஸ் பண்ணுங்கள், கான்டாக்ட் பண்ணுங்கள். நன்றி சார், நன்றி நன்றி, வணக்கம்.
Thank you, sir. A satellite concluding its mission and returning invaluable data to Earth. As every journey needs a fitting conclusion, I now invite Dr. Anbarasu, Association President, to extend the immense thanks.
Respected Father Secretary, Chief Guest of this function, Head of the Department of Physics, dear professors and my dear student friends. Good afternoon, everybody. Thank you is such a prayer that cannot be seen and touched. It must be felt by heart. I feel honored and privileged to get this opportunity to propose a vote of thanks on this special occasion Dr. APJ Abdul Kalam Endowment Lecture on this day. This day is very important in the history of physics because 18th December, it is today our international science community endowment lecture, and we are celebrating this event with our eminent scientist Dr. Gopalaswamy sir. So this day is very important in your history. I would like to thank all the honorable delegates and especially Reverend Father Secretary who blessed us with his presence and graced us with his kind words. Thank you very much, Father. And I also thank our beloved Father Principal for his constant support and moral support. Thank you very much, Father. On behalf of Physics Department, I convey my deep regards and hearty thanks to our Honorable Chief Guest, Dr. Gopalaswamy, for his thought-provoking lecture on why go to space. Thank you very much, sir. Our sincere thanks to Dr. Sundaraman and Dr. Ahilan for your presence and greetings this event. We will remain grateful to you and we thank you for being with us today. Thank you very much, sir. I would like to thank our beloved head of the department, Dr. Johnson, for his constant help and guidance that radiated a source of energy within us. Thank you very much, sir. I am very much thankful Dr. Che Charles, Dean of School of Physical Sciences, Dr. Kanikaraj, Head of the Department of Electronics, and Dr. Adul Arasu, the Coordinator of SIFT 2, and all my dear beloved professors. Thank you very much, sir. I would like to thank Professor Mary Dana, the Vice President of Physics Association, who welcomed us in this event, and Professor Noveen and his technical team, and my dear student volunteers, and all the students who supported for this event. Thank you very much. Finally, I thank you everyone, my dear students, research scholars, and professors, and all the delegates. Finally, I thank you very much. Thank you very much, sir.
To end this day on a note of unity and pride, let us rise for the national anthem.
Thank you.